Hey, what's up, guys? So today we're going to look at 6.3, which is properties / proving parallelograms. So this is actually going to be pretty similar to 6.2 in the sense of the properties are still virtually the same. The difference is for the last section, okay, we gave you pieces of information about a parallelogram and had you find the missing information using the properties. Now, you're essentially just going to be answering yes or no on whether a quadrilateral is a parallelogram and then justifying your reason with the properties. So property one, which we have stated before, if both pairs of opposite sides of a quadrilateral are parallel, okay, then the quadrilateral is a parallelogram. That's literally the definition of a parallelogram that we went over last time. So this is parallel to this guy is parallel to this guy. Two, if both pairs, and it's important that it does say both pairs, okay, of opposite sides of a quadrilateral are congruent, okay, then the quadrilateral is a parallelogram. Okay, so these two guys are congruent, these two guys are congruent. Opposite sides facing one another. Similarly for the angles, if both pairs, again, both pairs of opposite angles of a quadrilateral are congruent, okay, then the quadrilateral is a parallelogram. So that means this angle is congruent to this angle is congruent to this angle. Again, opposite, meaning they are facing each other. 4, okay, if one pair, so this is the only one where it only needs to be one pair. If one pair of sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So if you have a parallel mark and a tick mark indicating that these opposite sides are congruent and parallel, then we can conclude that the entire quadrilateral is a parallelogram. Lastly, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if you have this diagonal right here, pretend that slight curve didn't happen, and this diagonal is right here, okay? And you have that this half is equal to this half, and this half is equal to this half, then you can conclude that this, in fact, is a parallelogram. Okay, so we just have this example with 3 parts to it. So again, all we're doing is answering yes or no on if this is a parallelogram and then justifying why or why not. Okay, so for the first one, it gives us all 4 interior angles. Okay, well, the opposite ones on both pairs are not equal to one another. So the answer to this is no, because opposite angles are not congruent. Okay, next, it gives us the diagonals. Okay, so if this is a parallelogram, what we need to happen is that they bisect one another, meaning it is cut into 2 equal halves. Does that happen here? Yes, it does. 5 equals 5 and 3 equals 3. So we can say yes, because justification is always needed. Yes, because the diagonals bisect one another. Lastly, okay, well, it gives us that the opposite sides are all parallel to one another. That's literally the definition of a parallelogram. So yes, because the opposite sides are parallel. Okay, that's all I got. Thank you.